Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinitel. This is Suresh, Faculty of Chemistry. How are you all? Rahul Rajput, Surbing. So many students are waiting for the class. Wonderful, wonderful. So, nice messages I could see. Anyways, let us interact in the class while the class is going on. So, please be interactive. Please confirm you all able to can see me, can hear me. मैं आज आपको पेश करने वाला है aromatic hydrocarbons. In this aromatic hydrocarbons, the agenda for this is aromaticity and the benzene electrophilic aromatic substitution and reactive influences, direct influences of substituted benzene. So, definitely I can assure you that you are going to get one question based on the topic that we are going to discuss. Stay tuned. Everybody give a thumbs up and fire emoji to start the class. So, before going for this lesson, I just want to say what Infinity Learn is doing for the students preparing for NEET examination. Look at here, I would like to show 4 students here. Himadyuti, Ashrita, Akhil Varman, and Satyanarayana, and you can see the comparison between 2023 NEET score and 2024 NEET score. They completed their examination in 2025, 2024 and they are comfortable in very good medical colleges. Before coming to us, Infinity Learn, what they had just around 310, 313 marks. And after taking the classes with us and after following the academic drive from the Infinity Learn, you can see the score is more than 600. So, the score is almost getting doubled. How far? Yes, it is. You can see Ashrita got 310 marks in 2023, 661 marks in 2021, 2024, 350 marks, there is an increment. And also you can see Akhil Verma, who got 313 in 2023 and 658 in 2024, 345 marks is increased. And Himadyuti got 310 in 2023 and 652 in 2024 and 342 marks is increased. And you can see Satyanarayan just 330 marks in 23 examination and you can say 2024 में 650 marks. इनका score 320 marks बढ़ गया. So score is more than doubled. And not only this, for hundreds of students got like this, and you will be getting the score like this in 2025 NEET examination. Believe it, because you are attending the classes with Infinity Learn. All the best for your NEET 2025 and crack your NEET examination simply by attending the sessions with us and like these sessions and share with your friends and subscribe to Infinity Learn YouTube channel. And I just want to say, yes, your test prep with Infinity Learn. We have Infinity Learn app where you are going to see live classes, mock test, create your own test and 24/7 doubt resolutions. And also we have the Infinity Learn is on the platforms, social medias, YouTube and Instagram and Telegram and anywhere. So you can see in the Instagram and Telegram channel, in the description box a link is given and you can join in that and you can see in the Infinity Learn Telegram channel daily quiz and session schedules, session notes, session assignments and many more are there. So get use of that. Okay, anyways, आजकल आर्टिफिशियल इंटेलिजेंस AI का आपका हलचल ज़्यादा चल रहे हैं. So Infinity Learn is the first tool in India which uses AI in the academic drive. So what we are going to do here, goal settings, set your academic and skill enhancement goals. You will be having live classes by awesome faculty from the Infinity Learn and test paper preparation and paper analysis, in-depth analytics by AI tools, and also self-study, learn, practice and revise. You are going to have conceptual videos, mock test and practice test and also flashcards. And last but not least, doubt resolution powered by AI. Any doubt, any time, your doubt is going to be one click away. Mind it. So QR code is available, you scan it and you can enjoy the academic journey with Infinity Lane. And just last two more slides before going for the slide actual concept. Score examination, India's largest scholarship examination. Why it is India's largest scholarship examination? Because this score examination is given for the 1 crore worth of scholarships and study setup and laptop and educational allowances up to 100% scholarships. And that's the reason why I say it is India's largest. And you may be a student from Infinity Lane or may not be a student from Infinity Lane. You may be studying in any other institute, still you are eligible to write this core examination. Yes, dear students, get advantage of this registration form. You can click the link and you are going to get a registration form. You fill it and you enjoy the score exam. And the score examination is purely online, and you can write the score examination by simply sitting at your home. And also NEET 2025, last slide before I start the context. Stay tuned, be patient, bacho. So All India Test Series pack. So it contains 27 AITS examination and 25 NEET topic wise PYQs, 20 online NEET full syllabus mock test, 3 physics, chemistry, biology books, and also video solutions on the app, and detailed solutions and performance reports for every test, and benchmarking with your performance of the Sri Chaitanya students. These many facilities is given by Infinity Lane. So it was around 5,999. After you click the link in the description box and apply YouTube 50 off coupon code, then you are going to get a special discount for 2,999. It's a limited period offer. You all just click it in the description box and the pinned messages as well, and enjoy your seamless preparation with Infinity Lane. So shall we start? Aromaticity, the reactions of benzene, criteria of aromaticity. A compound is said to be aromatic, and what are the things you need to say to a compound to be aromatic? So this is the first condition. Molecule should be cyclic. This is a cyclic system, and this is a cyclic system, and this is a cyclic system. And these are all the systems where resonance is there but not cyclic. So this is the first criteria to say the compound to be aromatic. And as everybody, take a pen and paper and just write along with us. A beautiful content is ready for you, and I am going to explain in each and every point, bacho. And criteria number 2, molecule must be planar. In the ring, all the atoms supposed to be in the same plane. So it is a planar structure. This is a planar ring structure. Planar ring structure. It is a planar ring structure. Achho. Vinay Pratap Chauhan, good afternoon. And as compared to this cyclooctatetraene, आपको structure ऐसा बना देंगे. This is your cyclooctatetraene. उसमें आपको लग रहा है ये प्लानर सिस्टम है. ये सिस्टम ऐसे नहीं रहता है, ऐसे रहता है. इसे बाथ टब. इट इज नॉन प्लानर सिस्टम, नॉन एरोमेटिक होगा. एंड इज आल्सो नॉन प्लानर सिस्टम, एंड इज आल्सो ए नॉन प्लानर सिस्टम, है ना. सो if this compound is planar, then only you have to say whether it is aromatic or not. Okay, anyways, we are going to see, as points are there, I am going to explain each and everything. Let's see. The third point, molecule must be fully conjugated. I mean to say, Martha, good afternoon. Good afternoon. Vinay Pratap, good afternoon. Now all the atoms within the ring should be participated in the cyclic conjugated systems. Now you can see this is the electron is conjugated here. So it is a cyclic conjugated. So there should be a conjugation. Where you can see there is no conjugation here, conjugation is missing because of the sp3 hybridized. I wanted to say all the atoms within the ring should be sp2 hybridized. If some atom having a negative charge or the lone pair of electron, You need not have to follow sp3 rule. And also you can see molecule must have the 4n plus 2 number of electron in the conjugated pi electron system. So the molecule must have 4n plus 2 number of pi electron system. Let us say here it is a benzene. So the number of electrons participating in the resonance we can see. ये pi bond में 2 electrons है, 2 electrons पूरा मिलके 6 electron बन गया. And if you add this 6 electrons here, you simply add 4n plus 2 is equal to, ये 6 electrons substitute करो, solve for n. So हम n solve करने तो हमारा n is equal to 1. When you solve this n, you are going to get either 0 or 2, 3, 4, any number. You are going to 0 to infinity. That is going to be an aromatic compound. It should not be a fractional number. It should be an integer. Then only if first point, second point, third point, and this is the fourth point, if all the points are satisfied, then it is said to be a compound, is said to be aromatic. Bachcho, मान लो, based on aromaticity, you will be having a direct question, or you can predict the stable intermediate and stable products as well. Now you can see which electrons do we include this counting. So यहाँ पर electrons है, यहाँ पर भी electron है, यहाँ पर भी electron है. 4 electrons. So here 1, 2, 3, 4, 5, 6. 6 means 12 pi electrons. Sometimes we have to consider which electrons has to be considered. You only include electrons in the conjugated pi orbital, the perpendicular p orbitals. You can see all the p orbital which is parallel can be considered, which can be parallel to each other when it comes to the orbital structure. When you talk about this electron, this pair of electrons that is there, which is parallel to the p orbitals, so that this can be included. When compared to this pair of electron, no, this pair of electron is perpendicular to this, so this is not included. Are you getting or not? It's a beautiful interpretation in this organic chemistry. Martha and Vinay Pratap Chauhan. So you please ask any kind of doubts that you can experience in these slides. Okay. So everybody please take a pen and paper, write the tricks that I am giving you on the YouTube platform and be interactive here. I just want to say a simple trick. It is a thiopene, the electron pair, there are 2 electron pair, उसमें एक include करना और एक include नहीं करना. So one is included, one p orbitals are always perpendicular to each other. उसमें एक ही electron pair इस्तेमाल किया जाएगा और दूसरा pair इसका perpendicular में होगा, and दोनों का एक ही चलेगा और एक नहीं चलेगा. So ये क्या झंझाट नहीं है सर, कोई प्रॉब्लम नहीं. शॉर्टकट में आपका इतना बड़ा कॉन्सेप्ट का एक शॉर्टकट देना चाहता हूं बच्चों. If you have a ring system, in that ring system अगर ये इलेक्ट्रॉन जो है, it is only one electron pair is there, you can include in the conjugation. In the ring system already a double bond is there, this you cannot include. That is the simplest trick that I can give you. Bacho, hope you understand. Clear? Lovely trick. Everybody can use this anywhere, no exceptions. ये बहुत अच्छा शॉर्टकट है, आप कहीं भी इस्तेमाल किया जाओ अच्छा होगा. मार्ता, सौरभी भाई, राहुल राजपूत, क्लियर? नाउ आई जस्ट वांट टू से एरोमेटिक आयन्स भी है. इफ कार्बन positive charge carbonium ion or carbocation represents an empty p orbital, you can see carbon, okay, you are going to get empty p orbital. कहाँ पर है? Perpendicular to the plane of the triangle. So दिस इज ए प्लेन, बिकॉज क्योंकि कार्बन जो है ना ये sp2 हाइब्रिडेशन का हिसाब से. So while the C minus represents an electron pair on a p orbital, either can be a part of conjugated system. ये conjugated system में अगर cyclopentadienyl anion, this can participate in conjugation. And you can see cycloheptatrienyl cation, that is called trifolium ion, you are going to see the formation of the conjugation here. And cyclopropenyl cation is also having a conjugation. So such type of things, when you apply it is a cyclic planar systems and they are going to be aromatic. यहाँ पर n is equal to 1 आ जाएगा, n is equal to 1 आ जाएगा, n is equal to 2 आ जाएगा. So delocalized pi electron 6 electrons, here 6 electrons, delocalized सिर्फ 2 electrons. That is very important, right? And what is anti-aromatic compound? You can say 6 pi electron cyclopentadienyl anion. So it is aromatic system. And cyclopentadiene, there is no conjugation in this place. That is the reason why it is said to be non-aromatic. This is a non-aromatic. While you can see cyclopentadienyl cation just have 4 pi electrons. As this is having a just 4 pi electron, it is going to be anti-aromatic. So this is anti-aromatic. In this anti-aromatic system obey all the same rules of aromaticity, cyclic, planar and a conjugated system, but it failed to follow Huckel rule. Because of this anti-aromatic, it is highly unstable. Usually such kind of systems never exist. And talking about the generalized thing here, now you can see criteria of aromaticity. 4 points I want to give you. Molecule must be cyclic. So for this cyclic you can see these are the examples. Molecule must be planar and molecule must be fully conjugated. Resonance सारा का सारा circle में complete रहना चाहिए and it should follow 4n plus 2 number of pi electrons, that is called Huckel rule. And you are going to see this, if a compound follows this and this and this, then this, तभी a compound aromatic बोलना है. Okay, if the first and second and third point are accepted and fourth point is unfortunately accepted, it is said to be anti-aromatic. Anti-aromatic is unstable. Now you can say aromatic, non-aromatic and anti-aromatic. 1, 2, 3, 4, it is aromatic. Just 1, 2, 3, 1, it is violet. Any one of these first 3 points, you can say it is a non-aromatic, and if that fourth point is not accepted, it is said to be anti-aromatic. Okay, take a snapshot of this. It's very, very important. Bacho, Vinay Pratap, Surbe, Rahul Rajput, lovely. So thank you all for great support, and we are going to discuss about some points over here. So this is your examples. If anybody has any doubts, you can say. It is aromatic and it is also aromatic. This is anti-aromatic and it is also aromatic and non-aromatic, because it is planarity is missing over here, right beta? And it is phenanthrene aromatic and it is going to be non-aromatic and it is going to be non-aromatic and it is going to be non-aromatic. It is not at all a cycle. It is not at all a cycle. So like that, by looking at the structure, we can say whether it is aromatic or non-aromatic and anti-aromatic. Bacho, you can see So the most important reactions that are attributed to aromatic compounds are electrophilic substitution reaction. So on the aromatic ring system, one of the hydrogen from the ring is removed and replaced with an electrophile, that is called electrophilic aromatic substitution reaction. So you have 5 covalent reactions, 1, 2, 3, 4, 5 for the benzene. Benzene is the parent of all aromatic compounds, where you can see halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. In Friedel-Crafts alkylation and acylation, we are going to discuss an extensive way for this. Every reaction I just want to discuss in a mechanical approach. It's very important when you talk about this. And in the examination, NEET examination, definitely you are going to get a one question based on this. But so you can say, what about this generic mechanism of electrophilic aromatic substitution? Okay, Vijay Pratap Chauhan, you can see the benzene is first attacked with an electrophile, so that you are going to get an electrophilic attack, so that a new sigma bond is formed from the pi bond. So this is stabilized by various resonating structures. So this is what you call it as a sigma complex, as a resonance hybrid, you can say. So it is an intermediate. So the conjugate base, a proton transfer takes place here, so that this hydrogen is removed and the pi bond is going to be formed, so that hydrogen is replaced by an electrophile, that is what you call it as an electrophilic aromatic substitution reaction. बच्चों समझ में आ रहा है क्या? अगर कुछ डाउट है ना तो आप चार्ट बॉक्स इस्तेमाल कर सकते हैं बच्चों. Okay, now let us say in the generic mechanism, let's talk about halogenation. The halogenation, the benzene is treated with chlorine in the presence of AlCl3. You are going to get chlorobenzene. आप FeCl3 भी इस्तेमाल कर सकते हैं. ओके आप BCl3 भी इस्तेमाल कर सकते हैं. Any Lewis acid you can use. What is the meaning of Lewis acid? So this is an electron pair acceptor. So let's see the mechanism, we'll understand. So formation of the electrophile. जो क्लोरीन है ना, इसका लोन पेयर ऑफ जो इलेक्ट्रॉन्स given to the vacant orbital of the aluminum, so that this is broken here to form AlCl4 minus and electrophile Cl plus is formed. And so Cl plus है ना, and the pi bond is going to be attack on the Cl plus to form an electrophilic attack, and a sigma complex is formed. And this electrophile, it is resonance stabilized like this, so that you are going to get corresponding structure. समझ में आ रहा है क्या बेटा? It is a sigma complex, and you can see this proton which is actually there, which I don't show here. This hydrogen is removed from AlCl4, so that HCl is formed. AlCl3 is regenerated to form the chlorobenzene. So the reaction you can see chlorination, bromination, iodination. Fluorination you don't directly do it. We need benzene to fluorobenzene. सीधा नहीं कर सकते. Okay, you have to use benzene diazonium compounds for that. Okay. Anyways, you can see nitration of aromatic compounds. So benzene is treated with a nitration mixture, HNO3H2SO4, to give rise nitrobenzene. Okay, this nitrobenzene is very important ingredient in the perfume industry. So everyday use perfumes, deodorants and everything, the nitrobenzene derivative इसमें इस्तेमाल करते हैं मैं. Okay, anyways mechanism देखना चाहता हूँ. Step 1 formation of the electrophile. उसमें electrophile क्या होगा? उसमें electrophile NO2 plus होगा. इसका NO2 क्या चीज़ हो सकता है? Okay, you can see नाइट्रेशन मिक्सचर में HNO2 जो है ना, लोन पेयर H2SO4 को देता है. It acts as a Lewis base and it acts as a Lewis acid. Okay, so that you're going to get a nitronium ion as an electrophile. NO2 प्लस, आप NO2 प्लस भी लिख सकते हैं। ये इलेक्ट्रोफाइल बेंजीन को ऐड करने के बाद सिग्मा कॉम्प्लेक्स फॉर्म होगा, है कि ना। सो उसमें स्टेप 2 इलेक्ट्रोफिलिक अटैक, बेंजीन इज गोइंग टू रिएक्ट विथ नाइट्रोनियम आयन। इलेक्ट्रोफिलिक अटैक का अनुसरण आपको रेजोनेंस स्टेबलाइज्ड सिग्मा कॉम्प्लेक्स सीन। बच्चों समझ में आ रहा है क्या? जोर से। ओके, सारे के सारे सेशन नोट्स आपको टेलीग्राम चैनल में मिलेगा। चाहिए तो क्या करना, डिस्क्रिप्शन बॉक्स में टेलीग्राम चैनल का लिंक दिया, ओके, सब ऐड करना उसमें। नाउ व्हाट हैपेंड इन द स्टेप 3, रिस्टोरेशन ऑफ द एरोमेटिसिटी। सो द हाइड्रोजन इज रिमूव्ड, deprotonation from the hydrogen sulfate ion to gives rise nitrobenzene. Okay, मार्ता। ओके बच्चों, अगर कुछ डाउट है ना तो, अरे चार्ट बॉक्स में इतना पाके रखते हैं क्यों? एवरीबॉडी टेक ए थम्स अप एंड फायर इमोजी, कम ऑन। सो लेट्स टॉक अबाउट रिएक्शंस लिस्ट। सल्फोनेशन नेक्स्ट, थर्ड वन इज सल्फोनेशन। बेंजीन टू बेंजीन सल्फोनिक एसिड इज सल्फोनेशन रिएक्शन। उसमें क्या चीज मिलेगा? बेंजीन सल्फोनिक एसिड, उसमें रिएक्शन इलेक्ट्रोफाइल क्या होगा उसमें? SO3 is the electrophile. Which of the following is an electrophile? That's very important. So let's talk about here. Sulfur trioxide takes a proton from the sulfuric acid. So that electrophile you are going to see protonated sulfuric acid. So that pi electron यहाँ पे काट सकते हैं ना, देखो. So that pi electron is going to attack at the sulfur, protonated sulfur trioxide to give rise benzene sulfonic acid as a, this is the resonance stabilized by sigma complex, and finally you are going to get benzene sulfonic acid. मान लो ये reaction reversible हो सकता है. It's very important. It's very important. If you heat it little bit more by adding a little bit of water or sodium hydroxide, the reaction is going to be reversible. Now you can see the electrophilic aromatic substitution. Chlorination देखा, chlorobenzene, nitration देखा, nitrobenzene, sulfonation देखा, benzene sulfonic acid. ये reversible हो सकता, बहुत ही important चीज़ है, बहुत important चीज़ है. And और दो reaction बचा है, that is a Friedel-Crafts alkylation and a Friedel-Crafts acylation. बहुत अच्छा important है. Okay, let's talk about Friedel-Crafts alkylation. So how do you feel the slides today? How do you feel the slides? Somebody in the chat box, I want to ask you, how do you feel the slides? So these slides are made by handwritten script before I come to the session. Okay, so take a big applause for the tech team and my DTP operators team and PPT team. Okay, and my PPT team has made this and they made my lecture awesome. Okay, anyways, it is yeah, benzene reacted with alkyl chloride in the presence of AlCl3, which act as a halogen carrier, or you can also say it's a catalyst. You can also use FeCl3. You're going to get an alkyl substituted benzene. This is called alkyl benzene. So this reaction is called Friedel-Crafts alkylation. It can happen only with chlorine and bromine. If it is iodine, that scenario is different, and alkyl fluorides do not react in these reactions. Okay, let's see the mechanism. Bacha. In the Friedel-Crafts reaction, first of all, Friedel-Crafts acylation. If it is alkyl group, it is called as alkylation. If it is acyl group, this is called acylation. Understand? Clear? And you can say mechanism of the Friedel-Crafts reaction. When benzene is treated with tertiary butyl chloride in the presence of AlCl3, so you are going to get tertiary butyl benzene. Okay, let's see the mechanism here. Just like a chlorination reaction, you can see the lone pair of electron present in this alkyl halide is given to AlCl3 to form a electrophile. A carbocation is an electrophile. Now that carbocation is going to attack on the benzene, and it is an electrophilic attack. You are going to get a sigma complex. This sigma complex is going to be resonance stabilized, bachcho. Okay, and it is deprotonated from the sigma complex to get an alkyl substituted benzene. You see how smoothly these presentations are going on. Okay, so colorful presentation, है ना? You are like this, Martha and Vijay Pratap Chauhan. Now, the carbocation that is formed na, ye khatarnak hai. This is the carbocation. This is the carbocation. If chance is given, this carbocation can rearrange. Now, I just want to show you the carbocation rearrangement here. The carbocation rearrangement in the Friedel-Crafts alkylation. देखो, ये benzene reacted with this alkyl bromide. Okay, second. So, this alkyl bromide, what could be the possible products? What could be the possible products? It's an awesome reaction. In the NEET examination, ऐसे questions आने को संभावना है. So, questions are so tricky. Don't feel it is they are tricky. They are simple as possible. Okay, anyways, let's see. Beware of carbocation rearrangement. अगर कार्बोकैटायन डायरेक्टली ऐसा फॉर्म हो सकता है ना, दिस इज नॉट द मेजर प्रोडक्ट, इट इज इनकरेक्ट. यू से सर दिस इज द कार्बोकैटायन, ये कार्बोकैटायन लगाना चाहता हूँ, ये नहीं होगा, कभी नहीं होगा. ठीक है, अगर क्या होगा, सही आंसर क्या होगा, कार्बोकैटायन रीअरेंज कर सकते हैं. देखो, दिस ब्रोमीन इज गोइंग टू फॉर्म ए कार्बोकैटायन बेटा, दिस इज फॉर्मिंग ए प्राइमरी कार्बोकैटायन. सो कार्बोकैटायन स्टेबिलिटी क्या वजह से, प्राइमरी कार्बोकैटायन लेस स्टेबल देन सेकेंडरी कार्बोकैटायन, लेस स्टेबल देन टर्शियरी कार्बोकैटायन. सो इसमें एक हाइड्रोजन यहाँ से यहाँ एक शिफ्ट करने के बाद हाइड्राइड शिफ्ट बोलना है आपका, कार्बोकैटायन यहाँ बनेंगे. दैट इज व्हाट इज कॉल्ड टर्शियरी कार्बोकैटायन. प्राइमरी कार्बोकैटायन कंपेयर करने तो टर्शियरी कार्बोकैटायन ज़्यादा स्टेबल होगा. सो ये ज़्यादा स्टेबल होगा तो ऐसे काटना है बेटा. सो इट इज गोइंग टू अटैक ओवर हियर टू गेट दिस particular sigma complexed carbocation, and it is deprotonated to give rise actual product. Alternatively directly you can get it, that's a different matter. So this is the actual product you are going to get. So when you see the structures which is actually the correct product, so when examination is going on, this option also will be given, and you will be tempted to write the answer. It's a trap. लेकिन इसका असली आंसर क्या होगा, ये वाला असली आंसर हो सकता है. Are you getting or not बच्चों? Very important, very important. And also you can say methyl and ethyl halides react via SN2BA. So methyl bromide, it is going to, or ethyl halides are going to give SN2 attacks. And you can see multiple alkyls are the typical. You can see the alkyl groups in the multiple alkylations. Once the first alkylation happens, the ring is getting activated. Ahmad Raja, good afternoon. So multiple alkylation takes place because of the further ring is getting further alkylated. So once you got methyl bromide and benzene gives rise to toluene, and it is more reactive than this. This is more reactive than this. So it is going to attack one more methyl group, even more reactive. So it is going to give multiple methyl groups, and you are going to get so on. The multiple alkylation takes place, polyalkylation takes place during Friedel-Crafts reaction. So result, mixture of all possible products can be seen. That's very important, very important. Okay. Instead, we are writing, slides are made. And good afternoon, Ahmad Raja. Now, let's see the source of carbocation. If this is the source of carbocation, how it is coming it is not important, and how it is reacting is important. Let's see, this cyclohexyl cation can be obtained from chlorocyclohexane reacted with AlCl3. It can also be obtained from cyclohexanol when it is reacted with H2SO4, you are going to get a carbocation. And also you are going to get an alkene. When alkene is added with H2SO4, आप HFB इस्तेमाल कर सकते हो. So of course this is the carbocation. This carbocation is going to react with the benzene to give rise the actual Friedel-Crafts alkylated product, you can say. Ahmad Raja, hope you are understanding. Hope you are understanding. Thumbs up and fire emoji. So everybody please make a note of it. Wonderful. And you can see Friedel-Crafts acylation. Acyl group, acylated halide. Acid halides, when it is reacted with the benzene in the presence of AlCl3, you are going to get acyl benzene. So a new bond is formed between carbon to acyl carbon. So this is the old bond, it is lost, and a new bond is formed. So this is what is called a Friedel-Crafts acylation. Suresh Kumar, how are you? How are you? Miss you many classes. Okay, anyways, आज का जो क्लास में है ना, we are giving a good afternoon Suresh Kumar, a colorful rangoli version of the slides. Okay, good afternoon. Okay, anyways, let's see the mechanism over here, बच्चों. In this mechanism, formation of electrophile is seen. So in this, you are going to see the chlorine, lone pair of electron is given, so that acylinium ion is formed. This is an electron. देखने वाले Suresh Kumar, like these sessions only, right? So once it is deprotonated, restore aromaticity to give rise an acyl benzene. Here in the acyl benzene there is no multiple acylation takes place. Why? Because this acyl benzene is a ring deactivating group. This is a ring deactivating group. Okay, everybody just make a note of it. Suresh Kumar, fine. Yeah, any doubt? Ahmad Raja, Suresh Kumar, hope you can all see me. Wonderful. Martha, Vinay Pratap, Ahmad Raja is there and Suresh Kumar is there. Okay, anyways, let us compare the direct influences also. So Friedel-Crafts alkylation and acylation comparison. Substrate and reagent in the alkylation reaction, alkyl halide is taken into the consideration, and acylation you are going to get acyl halide is taken as in the reactant side. And also you can see a typical catalyst, you can use either AlCl3 or FeCl3, दोनों का बीच में हो सकता है. And complications here in the Friedel-Crafts alkylation, carbocation जो फॉर्म कर रहे हैं ना, ये खुद रीअरेंज कर सकते हैं लेस स्टेबल से मोर स्टेबल तक. ओके, where you can see acylinium खुद resonance stabilized है, that's the reason why it do not rearrange. Is very important. Here polyalkylation takes place, here polyalkylation do not takes place. polyacylation do not takes place. Okay, very good. Now let's talk about electrophilic aromatic substitution. और एक बार रिवाइज करना चाहता हूं. When benzene reacted with the chlorine in the presence of FeCl3 or AlCl3 are going to get chlorobenzene. This is called chlorination. उसमें electrophile Cl plus होगा. And HNO3 and H2SO4 you are going to get nitrobenzene. उसमें nitronium ion electrophile होगा. Nitronium ion electrophile होगा. ठीक है. And you can see SO3 in the presence of H2SO4 you are going to see this is a Friedel sulfonation, or you can also say H2S2O7, you can say fuming sulfuric acid. उसमें sulfur trioxide itself is an electrophile. And RCl AlCl3 Friedel-Crafts alkylation, alkyl carbocation is the electrophile. And RCOCl you are going to get RC double bond O, and this is called acylation, Friedel-Crafts acylation. Acylinium ion is the electrophile. So this is the summary of the electrophilic aromatic substitution reaction. And the directing effect in the electrophilic aromatic substitution reaction is very important. Here main course comes as NEET examination में इसका वजह से ज़्यादा questions आने का संभावना है. Okay, now you can see OCH3, this is what is called as anisole. Methoxybenzene, when it is reacted with the Cl2 in the presence of AlCl3, you are going to get O-chloroanisole, M-chloroanisole, P-chloroanisole. Here, this methyl group present on the benzene decides where the incoming electrophile should come and attack. Ahmad, you can say, Suresh Kumar, you can say why this is resonance, why this is given as a major product. And I just want to show you by various resonating structure. When this anisole is resonance stabilized due to positive mesomeric effect or positive resonance effect, electron is coming on the benzene, so that you are going to see the negative charge accumulated on ortho, negative charge accumulated and para, negative charge is accumulated at again ortho. In this resonance hybrid, the negative charge is accumulated at ortho and para position, so that electrophile यहाँ काटने का ज़्यादा मौका देता है. Let's talk about the energetic graphs also. You can see this chlorine can be attacked. You can say अगर क्लोरीन आर्थो से अटैक करने तो, मेटा से अटैक करने तो, और पैरा से अटैक करने तो, अगर पैरा से अटैक करने तो मेजर कंट्रीब्यूट होगा, आर्थो से अटैक करने तो मेजर कंट्रीब्यूट होगा. आयुष कुमार, thank you very much for your great compliments. And take a pen and paper, you are going to write the useful content also. Ayush Kumar, thank you. And keep discussing and chatting in the chat box, so that the session is going to be a live and interaction will happen, right? Okay, anyways, let's see. When anisole is attacked with the electrophile, activation energy पैरा एनिसोल अटैक करने तो ये एक्टिवेशन एनर्जी कम से कम होगा, whereas in the मेटा इसका एक्टिवेशन एनर्जी ज़्यादा से ज़्यादा होगा. That's the reason why it forms faster and it forms the major product like that. That's the reason why you are going to get the major product as it requires the least activation energy. Ayush Kumar, fine? Clear? Wonderful. Now let's talk about activating groups. क्या चीज हो सकते हैं? Any group which has a positive mesomeric effect or positive resonance effect can be an activating group. Like you can see here, strongly activating group like OH, OR, NH2, NR3, or moderately activating group like SH, SR, O, C double bond O, R, and NC double bond O, R, ester and amide. And slightly activating, weakly activating group like methyl groups and phenyl groups. This phenyl group is actually a chameleon group. Let's talk about nitro group on the benzene. This is a deactivating group. So why this is deactivating? नेगेटिव मीसोमेरिक इफेक्ट का वजह से इलेक्ट्रॉन बेंजीन का बाहर जा रहे हैं, so that you are going to see the positive charge that is accumulated on the benzene ring. So electrophile खुद का positive charge है, ये positive charge cannot attack on the positive charge. So electrophile काटने के यहाँ पर नाइट्रोबेंजीन में संभावना कम कर रहे हैं. So that is called ring deactivating. So nitrobenzene is less reactive as compared to benzene, and anisole is more reactive as compared to the benzene. So positive mesomeric effect makes the benzene ring is more reactive, and negative mesomeric effect makes the benzene nucleus less reactive. Okay, that's very important. या आगे बढ़ते हैं. आपका जो नाइट्रोबेंजीन है ना, अगर क्लोरिनेशन करेंगे तो क्या होगा? यू आर गोइंग टू गेट ऑर्थोक्लोरो, मेटाक्लोरो, पैराक्लोरो. सो व्हेन यू टॉक अबाउट दिस nitro group, here positive charge is there. So if an electrophile want to come and attack here, electrophile can come and attack here, because the positive charge place it can't attack, no? That's the reason why you are going to get a major product as a meta. Whenever deactivation takes place, na, meta is the major product and it is very less amount is formed. And reaction mechanism the same thing. So here when you talk about the activation energy for the meta, इसमें कम से कम होगा depending upon the activation energies. Depending upon the activation energy. So if you want to attack at the para or you want to attack at the ortho, so what happened? You are going to get an unstable carbocation. Unstable carbocation. That's the reason why only meta is going to be formed. You can see the energy diagram. So nitrobenzene से मेटा क्लोरो पोजिशन का अटैक करने का ये इंटरमीडिएट का एक्टिवेशन एनर्जी कम से कम होगा. सुरेश, so from here you are going to get the meta product. So let's see what are the groups deactivating, strongly deactivating. CF3NO2 NH3 plus, they are super strongly deactivating. So moderately deactivating and moderately deactivating and weakly deactivating. So halogens are weakly deactivating, exceptionally they are ortho and para directing. That's a exceptional, that is exceptional. All the acid derivatives are going to be moderately deactivating because they will be having the cross conjugated systems. And also you are going to see strong activating and strong deactivating. So activating and deactivating group reactivity spectrum is very important to answer the type of questions that are there in the organic chemistry. For the NEET perspective, this slide, everybody take a snapshot of this. 3, 2, 1. Okay, आगे बढ़ते. So example 1, when क्लोरोबेंजीन HNO से रिएक्ट करने तो ये ऑर्थो एंड पैरा डायरेक्टर का है, so that you are going to get ortho and para product. Among ortho and para, generally para is going to be the major product. Sometimes ortho can also be, it's a different matter. So let's see another example over here. If nitrobenzene is taken, nitro group is a meta directing group, so that chlorination happen, metachloronitrobenzene is the only product can be formed. And also you can see there is a ketone that is attached to the benzene. So of course it is a ketone meta director. When nitration takes place, ये ग्रुप का हिसाब से ये मेटा पोजीशन में नाइट्रेशन करना है. आर यू गेटिंग और नॉट बच्चों? क्लियर? That's very good. Now let's talk about nitrobenzene. When acylation takes place, there is no reaction. There is no reaction. Why? Somebody, if anybody knows the answer, mention in the chat box. Come on, I am waiting and I'll ready for discussion about this particular point. Come on, jaldi. Ayush Kumar, Suresh, Ahmad Raja, Martha, Vinay, Pratap Chauhan. Now let's see why nitrobenzene do not undergo Friedel-Crafts reaction, because it is strongly deactivating group. Strongly deactivating group. And multiple directing effects and introduction of multi-step synthesis. How it is? So if a group nitro is there and an anisole group OCH3, so this OCH3 है ना, इसका पॉजिटिव रेजोनेंस इफेक्ट होगा, इसका नेगेटिव रेजोनेंस होगा, so that the electrophilic aromatic substitution reaction takes place with respect to the ring activating group. So इसका वजह से आपका मिलेगा है आइसोमेरिक प्रोडक्ट. So as this is your pair, इसका वजह से ये आर्थो होगा, इसका वजह से पैरा होगा, because it's the major product less sterically formed, and you are going to see a meta product. This is not the actual product that can be formed. Okay, this is not formed, this is not formed. Understand? And let's say the multiple products here. अगर electron donating group होगा, ring is getting activated, makes it ortho and para position negative charged. Okay, Arjun. Anurag Singh, thank you very much for your compliment. Okay, so an electrophile is more likely to attract the ortho and para position to the electron donating group, EDG, electron donating group. Okay, electron donating group. Understand? Clear? Now let's see, अगर ये चीज इलेक्ट्रॉन विड्रॉइंग ग्रुप होगा तो यहाँ पर पॉजिटिव चार्ज होगा. इलेक्ट्रोफाइल यहाँ ये जगह में काटने को मना है. So that withdrawing group deactivate the ring, makes the ortho and para positions positive charge. So okay, let me check, the lag is coming. Okay, now it is resumed. Now it is resumed. Anurag Singh, you please confirm. Suresh, you can confirm. You all able to see me? You all able to can hear me? Okay, let's see. The next one is going to be example here. OCH3 and O2 is there. Cl2 in FeCl3. You are going to see the formation of this is the major. We already seen this. And you can see example 2. Now this is a cyclic ring system because of this negative mesomeric effect and because of this positive hyperconjugation. This is called hyperconjugation. So this part is going to be activated. So this is activated and ortho and para. इसका वजह से ये नहीं होगा. So that the respective acylation products are going to be like this. Now you can see it could be either major or minor, नहीं बता सकते. अगर ये वाला है काटेंगे तो this part is making a repulsion here. That's the reason why this is less probable product. Understand? Less probable product. Okay. Now let's see in this conflicting direction effects. So we are going in more effective version. More effective version. मजा आ रहा है ना अनुराग? Here methyl group is there. N dimethyl para is there. So ये weak activating क्योंकि ये वाला hyper conjugation का वजह से ये वाला पॉजिटिव रेजोनेंस के वजह से among resonance effect and hyperconjugation effect, resonance effect is more effective, so that the substitution takes place with respect to this. So you are going to get a major product here, ortho or para हमेशा block में है, so you are going to get a ortho substituted product, ortho acylated product. It's a super awesome example. You can say stronger the activating group has a stronger influence on substitution reaction than the weaker one. That is the logic over here. Got it? That's a super content I just want to give you. And और एक चीज है, now activating वाला stronger activating, this is a stronger activating and this is the stronger deactivating. दोनों के stronger, लेकिन activator के हिसाब से product बनाना है. Are you getting or not? Clear? Wonderful. So stronger is the activating than the deactivating. So stronger activating group is going to be decide what the product can be formed. And like you can see, sometimes nitro group is deactivating and here nitro group is deactivating. So whenever this deactivation in both sides are happening, this group is utterly locked and substitution reaction do not takes place. Okay, so such type of things do not participate in the electrophilic aromatic substitution. The entire ring is to deactivated, so no reaction beta. Wonderful. Alright, now accomplish the following synthesis by using benzene any other necessary reagent. Benzene से ये product कैसा बना सकते? Okay, you all take a pen and paper, try to write it, you will understand. So this may be probably the last question of the day. So hope today you enjoyed the class. Okay, now let us see how that can be done. You can see this is ortho and para director, add via Cl2 and FeCl3. This is the meta director. So add via acylation, Friedel-Crafts acylation. So there are two things can be done. Okay, one is you can say option 1 halogenation then Friedel-Crafts reaction. अगर halogenate करो Friedel-Crafts reaction करो para product मिल गया. This is the wrong product. I don't want this because the question is a meta वाला. ताकि ये है option 2 you just Friedel-Crafts acylation करो बाद में halogenation करो. This is the correct product. So what is the actual process you need to understand. Clear better? Hope you enjoyed. So Friedel-Crafts alkylation I synopsis का है. Okay, and advantage of Friedel-Crafts alkylation, acylation, polyacylation do not take place and only one product is formed. So intramolecular Friedel-Crafts acylations भी हो सकता है. So here chlorine is gone. Now the acyl carbon atom is going to form and this is called Friedel-Crafts acylation. So like that you are going to see so many awesome concepts during the live session with Infinity Learn. So बच्चों, hope you enjoyed today's class. We started what is aromatic ring and aromaticity, non-aromatic, anti-aromatic, then electrophilic aromatic substitution, and in that chlorination, nitration, sulfonation, Friedel-Crafts acylation, Friedel-Crafts alkylation, and mono substituted direct influence and poly substituted direct influence. And like that we have seen a lot more in today's session. So stay tuned for such type of live sessions. Every day I am coming up with one concept and will be discussing the things with you. If you have any specific doubt, mention in the comment box so that I am also going to discuss that particular topic exclusively for you, simply if it is free of cost. Okay, so Infinity Learn Studio से हम बच्चों लोग के लिए कुछ भला करने का कोशिश करता हूँ. So आप भी हम भला करने का कुछ कोशिश करो. Simply like, share and subscribe to Infinity Learn NEET YouTube channel. Thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. Bye bye. Thank you.